It was the year 1928 when Paul Dirac was trying to figure out what exactly happens when you try to move matter at the speed of light. He had an equation ready, and every time he used to solve that equation, he used to get two possible solutions. Think about it this way: every time you try to solve the root of 9, you get two answers, that is, the positive 3 and the negative 3. Same happened in this case. Thus, he researched a little and he concluded that there is an existence of antimatter. So, what exactly is antimatter? Antimatter is something that shares the same properties as that of matter, that includes your mass, your volume, but the only difference is the charge that it carries. So, let's say if you got an electron will have an anti-electron that has got the same mass, same spin, but the only thing that's different about it is the charge. So it carries actually a positive charge. Eventually, there are many subatomic particles in such way, like you had antiquarks, antineutrinos, antimuons. And it was later in 1932 that this theory was actually confirmed when Carl Anderson managed to take the first ever picture of an antimatter. Now the question arises, why are we so into antimatter? What makes it unique? Well, number one thing is the fact that when matter and antimatter comes into contact, it annihilates a huge amount of energy. Now this is extraordinary in order to channelize energy. If we are able to harness such high amount of energy, we could revolutionize the way we think or way we live our life as a whole. But the problem is that we are not able to find a high amount of antimatter. What happens is antimatter exists naturally in possibly only 4 or 5 different ways. So one is beta decay, one is cosmic rays, nebulas, and very less concentration of antimatter actually exists. But matter is an extremely high amount. So we are not able to find the right amount or create the right amount of antimatter. So there are many researches that are actually being conducted on this in Fermilab, where they're actually taking high energy photon lasers and high energy photon rays, and they're bombarding it in such a way that there is an energy that has been created out of it, eventually giving a birth to antimatter. But then the question still arises is, can we find a much more efficient way? The bigger question that troubles physicists is, during the Big Bang, if there was same amount of matter and antimatter, why is matter in a way higher volume? Why is there more matter than antimatter? Or is it possible that there is an existence of, I don't know, maybe an anti-planets or anti-universes? So there's a lot about antimatter that is yet to be known, and there's a lot of research that has been conducting, and only time shall tell what can we figure out about antimatter.